Okay, so radiation. What exactly is it? Well, it was discovered by someone that most people have heard of, Madame Curie. I think it's Madame Curie. I don't know, her name has sort of like a mystique associated with it. And she discovered an element called radium. And she thought it was wonderful stuff. She thought it was so wonderful that they were even drinking it. Not a good idea. She died young, as you might imagine. Okay, so you don't want to be drinking radium or any of these radioactive compounds, but everyone's heard of her because she discovered radioactivity. Now, radioactivity is what? Radioactivity is the spontaneous emission, that's like a release, the spontaneous emission of radiation by certain elements. Not all elements do it, just some of them. Now, what are the different kinds of radiation? We were just talking about neutrons being released. So one of the kinds of radiation is what we call alpha particles. And alpha particles consist of 2 protons and 2 neutrons. That's what we were talking about before. And so that means if you are releasing protons, you're going to become something else, right? We said the number of protons determines the identity of an atom. So radioactive decay, we'll talk about that, is the progression of elements that you become as you release the alpha particles. Another kind of radiation is beta particles, and this is just electrons, high energy electrons. So the atom doesn't change identity, right? It's just electrons. And then we have this super colossal powerful stuff. We had said it has no mass. Remember, we had talked about the energy spectrum, and we had said we have your radio waves, we got your microwaves, your infrared, visible light, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. And we're getting more and more energy, and we're up there in that, real short, high energy stuff. So that is what radioactivity is. What else do we want to say? So I already mentioned this. I said when an atom releases alpha particles, it changes identity. So the alpha particle loses protons, so it's going to change identity, and so a nucleus decays to produce another radioactive compound when it's losing this. Okay, we have a decay series for you to look at on page 245. So make sure you look at that. Page 245 in your textbook is going to be showing it becomes this, becomes that, becomes the other thing. So what is another term? Another term that we think of when we think of radioactivity, when you have these scenarios where we talk about, the atomic bomb, you might say, well, how long before it's safe to go back? And I'm sure you know this, actually. You'd say, it depends on the half-life of the radioactive substance that's left behind, the residue, so to speak. And so the half-life is the time that is required for the level of radioactivity to fall by 1/2, become half, makes sense. So when we think about nuclear bombs and all those kind of horrible scenarios, plutonium is one of the major, components of bombs, I guess, today. I don't know, I'm not a nuclear bomb expert, but plutonium has a half-life of 24,000 years. Yikes. Not good. And Regular uranium, uranium-238, which is radioactive but can't be used in the nuclear fission process. Oh, it's a 4.5 billion year half-life. So you don't want to mess with it either. Okay, so let's stop right here and